All right, everybody. Mr. Barry here. We're going to be in this quadratic unit, um, and we're going to take a look here at some problems where we can go ahead and graph the vertex form of a quadratic function. So we know that we have a quadratic function here. We know that this should appear as a parabola, and it has everything that goes along with being a parabola. But this function in particular is definitely written out for us in vertex form. So with that being said, the very first thing we want to check out, if it's in vertex form, of course, would be the vertex. So we're going to come over here. We have -2 times the quantity x minus 5 squared plus 3. And right from the get-go, hopefully for you, this is not a terrible thing to figure out at this point what the vertex would be. We look inside this parentheses here, and we have x minus 5. We're trying to figure out what it is that would give us a 0. So what number would we plug in there? That operation would give us x is equal to 5. That's our h value for the vertex. And we know that the back end here, the plus 3, would be our k. Alright, so when it comes to figuring out the vertex, there's not a lot of math work involved, but we certainly know that for this quadratic function here, we would have an x value of 5, a y value of 3. I'm going to go ahead and I'm going to plug it up right here onto my graph. Now it's probably not a terrible thing to know, but if I take a look up here, our a value is -2, so we do know that because our a value is a negative number, that our parabola is going to be going downwards, which means our vertex is a max. Alright, so again, since the a value is negative, our parabola is going to be going downwards, which means this is the highest location on the chart on the graph right here. So I'm just going to go ahead and label it right here for us right now, just to have that information there for us. It's going to be important when we do more application type problems. The next thing up that I would suggest to all of you is that we take some numbers around x and figure out what the y values would be. All right, now this will involve a little bit more computation. We're not necessarily given as much information as what we've had before, so we have to go calculate some things out. But the nice thing with that concept here is that if my vertex is 5, 3, then I certainly know here that my axis of symmetry would be that 5 as well. So x is equal to 5 is my axis of symmetry. It wouldn't hurt for you to go ahead and, as we've been doing here the last couple weeks now, drawing in our imaginary line. That's our mirror for this parabola. So we know that on either side of that mirror, on the axis of symmetry at x is equal to 5, that we would have mirrored images when it comes to different points. So I'm going to go ahead and pick another number. I'm going to go ahead and pick the number 4. It's right before 5. It just seems like it would be an easy thing to do. And this is something that we're going to go ahead and need to calculate some things out. So I'm going to come over here. I'm going to plug 4 in for the letter x. So there is some computation. Maybe you're someone that feels comfortable using a calculator at this process, and you can type in that whole thing right there, but just in case that's not you, let me go ahead and show you some work. 4 minus 5 would be -1, and we got to remember that the order of operations tells us to square that first before worrying about the -2 out in front. So -1 squared is +1. And then I want to go ahead and do -2 times 1 would be -2 plus 3, and that is equal to 1. So my x value is 4. I figured out that when my x value is 4 for this function, my y value would be the number 1. I'm going to go ahead and put that over there in my table of values. Go ahead and graph the picture here. We have 4, 1, 4, 1 right there. 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, Now we want to think a little bit smarter, not harder, or excuse me, work smarter, not harder, I should say, with this, and understand how we can use this mirror to kind of cut out our work half the way. So what I mean by that is if 4 is one spot away from the number 5, 6 would also be one spot away from the number 5. It's just on the other side of our mirror right here. And we understand that if that's the case for the mirror, that if 4 has a y value of 1, 6 should also have a y value of 1. Now I can go ahead and I can compute that out, and I can do some math work on that and figure out. But if we understand how the mirror works, then we don't have to do that. So I have 3 points right now. I'm going to continue the process of just picking numbers that are relatively close to the vertex here. I'll show you why in a minute after I get these next 2 points. But I'm just going to go ahead and pick the number 3. So I went with 4, now I'm going to go with 3, which is technically 2 spots away from the x value vertex, 2 spots away from the axis of symmetry. I'm going to go ahead and plug it in and do some math work here. Again, maybe at this point you feel comfortable enough just to type this all into a calculator. That's fine with me. But in case you want to get the computation down, -2 squared is +4. Then I multiply. Then I add. So I have, when my x value here was 3, my y value was -5. When my x value here was 3, my y value was -5. I'm going to go ahead and plot that point over 3, and then I'll go down 5. 1, 2, 3, 4, 5. There it is. And again, I'd like to have at least 5 points for the parabola here. I want to use that mirror and try to work smarter, not harder. Trying to get that expression down at some point here. So 3 is 2 spots away from the number 5. Another number that is 2 spots away from the number 5, going in the other direction, would be the number 7. Since 3 has a y value of -5, 7 would also have a y value of -5. So again, I can go ahead and write that in my table of values. I can go ahead and graph it. It should kind of, sort of, just right from the get-go look like it's mirrored across that axis of symmetry for our parabola. I'll go ahead and connect the dots now that I have my 5 points. Again, we're going to try really hard to have at least 5 points for each of these. We can certainly see that that vertex point was a maximum within this problem. So I was able to draw my parabola, starting off by getting the vertex first, and then really using that vertex to kind of base things here. I had to do 2 computation problems, but using that mirror, it's only 2. I don't have to do all 4 outside the vertex with that. The one last thing I want to note here, and this problem would be this is done, this is beautiful, it's great, but eventually when we get to the application problems, I want to make sure that we understand the concept of the y-intercept within this problem. And I'll compute it out, and then hopefully you'll see why I avoided just going and finding it right away here, and instead find numbers close to the vertex. So I'm going to do the math work over here, and again, this is extra. This is me trying to figure out what the y-intercept would be. When I'm trying to find the y-intercept, my x value is always 0. So I'll go ahead and I'll take our function that we started off everything with, and I'll plug in 0 wherever I see the x. Do some math work here. -5 is going to get squared eventually. -5 squared is +25. -2 times 25 is -50. And then I would have to add the 3 at the end And I do my math work and I get that y is equal to negative 47. So for this problem, you can kind of sort of see this in the picture. It's going to be a while until we actually hit that y-intercept. And if I'm dealing with a graph like this that only goes to, I think, spot number 12 or something like that, I don't necessarily want to, when we're algebraically solving these things, rely on the y-intercept. It might come up in the course of a problem, but we are going to try as hard as possible to pick numbers for x values that are relatively close to the vertex here. So I went 1 away and then I went 2 away. So again, my y-intercept for this problem would be the point 0, negative 47. We might need that in our application problems later on, so I definitely wanted to show you how to do that. But for now, that's a point that would be awfully tough to graph. So we're perfectly fine picking the vertex, or finding the vertex, calculating 2 points, okay, using the mirror for the other 2 points. That makes a total of 5, and we're happy. We have an accurate looking like graph like right there.